Welcome to the next section of communication and technology. So last time we have looked into the history of tools that people developed for communication. I mean, technologies to communicate before they invented writing. Today we will look into the next stage, which is writing, which I gave the catchy title, the alphabet. However, this is a bit unfair. Not every writing system that people use is alphabetic, as we shall see. So, if you remember the pictures that I took from the nice book by Andrew Robinson, so Robinson shows how the first writing system that we know of has evolved from these logograms, these depictions of actual things that you could, with a bit of imagination, recognize, like someone eating, into abstract forms that represent the eating here. And from that on, probably into an alphabet. So this is a general way how it seems all alphabets, all writing systems in the world seem to have evolved. So if you look at this nice chart that I have from this French textbook, uh, uh, for example, in the top box, first row, you see a fish, first kind of in an abstract form, but you can still see the fish, and then it becomes more and more kind of this cuneiform letter-like symbol, or the bird in the second row. And the same is true for the Egyptian writing, the ancient Egyptian writing that developed independently from the cuneiforms in Mesopotamia. So the Egyptians also had these logograms like a fish, and from there came more and more to what today we would see as a letter. And this again with the Chinese. So in East Asia, it is now believed that the development of the writing system in China happened completely independently from the Middle Eastern and European writing systems. And nevertheless, we see the same pattern. We see the fish evolving into the abstract logogram. Same with the bird or the axe or the arrow. So it's the same principle of forming a sign from the concrete logogram, the icon representing the object, to the abstract. Well, so the cuneiform is believed to be the oldest proper writing system. So cuneus in Latin means wedge, in German Keil. So the cuneiforms are in German called Keilschrift, which is a word that you find quite often in more ancient textbooks, because there was so much German scholarship on the Middle East. So if you look at these cuneiforms, how they came to us today, it's very often in the form of clay tablets. So we have seen that in the last session, these clay tokens and clay tablets for accounting and bookkeeping and having a calendar. And that is most of the cuneiform writing. Thousands and thousands of these clay tablets have survived over the millennia, the 6,000 years that they have been around. Most of them have not yet been transcribed. So just recently there was this super interesting guest lecture, the archaeologist doing excavations in Oman, who could tie ore mining and copper production in the Hajar Mountains with cuneiform tablets found in the Assyrian empires thousands of years ago. So people in Mesopotamia would write contracts with the people in Oman, what is today Oman, what is today the Emirates, where they would, for example, specify the amount and quality of the copper to be delivered, and then also we find complaints that people write about the lack of quality of the ingots that were delivered and demanding refunds or delivery of an exchange. So it's economical, it's mundane things that we find in the abundance of these cuneiforms. Most of what was written you find in these slabs of clay where people use a small wedge to imprint the wedge-like symbols. And that is not the only way that they would write. There is, as we shall see, stone inscriptions, but also a lot of writing was done on wax tablets. So they would have this book-shaped tablet of wood, and would have a small sheet of wax on one side. And the advantage of a wax tablet is that it doesn't dry out. I mean, the clay gets dry. It doesn't even need to be burned to get hard. While the wax stays, in particular in the climate of what is today Iraq, of course, stays soft. And so you can write your notes down and erase it and write again. So that's very handy. But unfortunately, of course, all that is lost except for very few examples that have been found and miraculously survived. So the wax tablets stayed around for a long time, and as we shall see also, the form of this book-shaped tablet becomes the leading paradigm of binding books then, like 2000 years later in medieval times in Europe. So most of these clay tokens and clay tablets are rather small. So you see my finger here pointing on it. This is in the British Museum in London. There's a large collection of these tablets there. So they were tiny, and the stylus on which you would write is also tiny. It's almost a needle. It's very hard to read, in particular if you think that the lenses for having glasses had not been invented. So it's very economical. Can amount a huge amount of letters on one tablet. So these are other examples there in the Pergamon Museum in Berlin. And you see there also intricately written on its letters. It's a letter exchange between kings. So the one king writes to the other and tells about strategic developments and asks for favors and tells the other king about where the boundaries should be set and so on. So it's political documents that we have found. They are not sacred documents. They are totally mundane. While the tablet is such an amazingly handy form of doing information, of having a communication device. I mean, these are examples, early 20th century examples of calculators where you have a stylus to move around these levers to add and subtract. And of course, we all know what came out of that. That is smartphones. So the BlackBerry, a tablet-shaped slab of glass and metal where you have a keyboard. I like that very much because I am trained to write with my fingers. It was much easier to think of that for a long time for me to have a touch screen. But then, I mean, the touchscreen made it with the iPhone in 2006, or here the Google Nexus 1, which was the first phone put out by Google, the first major success of an Android phone 2 years later. So there you see the tablet format. This is, by the way, the first digital tablet that was produced by Apple in the 1990s. So they were way ahead of their time. It had a stylus, and you write on the stylus, has character recognition of your hand writing, and could be connected via modem to your computer. So that was not a success. It was too heavy, and the battery life was not long enough. But Steve Jobs, the CEO of Apple, completely stayed to this vision until technology was ripe, and he came up with the iPod 10 years later. Always fun to think of the persistence of this style. So this form factor. So Ferdinand Waldmüller, a southern German or Austrian painter of the late 19th century, in his famous painting, The Expected, you see the poor guy waiting for his beloved girl, has flowers in his hand, but she doesn't pay any attention because she is, well, what looks like texting. I mean, of course, that can't be the case. We all know that must be a book, but I think that the way of being distracted by your tablet in your hand, your mobile device, be it a small book or a phone, is really striking. So this is technology. I mean, it's stuck with us. We use the same things, and then people did thousands of years ago, at least by the form that it has, because it is so much human shaped. Back to the cuneiform. So not everything that people in Mesopotamia would write down was in clay. More important or persistent documents were written in stone. And this is one of the most important documents that has made it to our time. It was written for or by the Babylonian king Hammurabi. He was the sixth king of Babylon around 1800 before our time. So that is about 3,800 years ago. So that's in biblical times, literally. It is really the beginning of long text writing, and the Codex is believed to be the first written law that we know of. It is actually a collection of 282 laws, in particular criminal law, that prevents excess punishment. So it is the eye for an eye and tooth for a tooth law that we know of also from the Bible. But it was not meant to be harsh, it was the opposite. It said you can't exceed the punishment of someone who does wrong above the damage that this person has done, which of course can be debated. I mean, what that means, if it is not as straightforward, just by someone loses an eye and then you take someone else's eye, and of course that is not very meaningful in the first place because that doesn't help the person who lost the eye in the first place. Nevertheless, this retaliation idea to curb that is seen as kind of this first attempt of a king to prevent violence in the civilization that existed. I mean, in the tribal culture, you don't need that because it's kind of clear that people deal with wrongdoers on the level of their family and kinship relations. But in a city state, as Babylon at that time, which was huge, it was probably 160,000 people living there. It was probably the largest city in the world at that time. It was necessary to codify because there is no direct relationship between, necessarily at least, between someone who is a criminal wrongdoer and the victim. So it had to be codified to keep things working. Other laws in the Codex Hammurabi deal with liabilities. So, for example, what happens if a craftsperson builds something and that thing doesn't work? So in the easiest case, there is kind of a warranty. So the craftsperson has to replace it. But if something happens, if a damage happens, the craftsperson is liable for the damage. For example, if a building collapses, the the builders who built the building are liable for the damage done, including the loss of lives. The same is true for the surgeons, who would also be held liable. On the other hand, both the craftspeople, the workers, and the surgeon are entitled for proper payment. So this is all the laying ground for an abstract way of organizing economy at this early time. So it's no longer possible for people in these city states, in these civilizations, to maintain relationships on a pure handshake basis. That's not how things work because there's too much disagreement. And to keep peace, at the time of Hammurabi, 3,800 years ago, it became necessary to write things down in stone and have that on display on the marketplace so that when people didn't believe that that was the law, you would just go there and say, well, look at the law as it is written in stone. This is how it says. If you look at the details and zoom in, you see the beautifully written cuneiform, tiny scratches in this very hard stone. So it's a granite, so that really lasts forever. Another law, about 500 years later, is the so-called women's law, which is an Assyrian text written under the Assyrian king Tiglath-Pileser. So that's around 1100 BCE, so about 3,000 years ago. And this law is totally different. It is here in Berlin, in the Pergamon Museum, where you see people admiring it. It's really one of the major sites there because it is so drastic regarding what it tells about the relationship between the genders. It is such harsh rules what women should do and what they are not allowed to do. And it is such cruel punishment in all kinds of, I would say, relationship and propagation and having children relating facts. So there's all this cruelty that women have to veil, that it is not allowed for women to talk to men, that it is seen already as adultery if a married woman talks to another man without the presence of her husband, and so on. So this is really interesting to see how early this discrimination against women I would say in our cultural sphere has been codified. So there is a whole theory how that came to be, because many of the old civilizations were quite egalitarian. The old Mesopotamian law that you see, for example, in the law of Hammurabi is much more egalitarian. So women have much more liberties and it's much more equal between men and women. And it's believed that other ancient civilizations, like the Indus River Valley civilization, was likewise not as patriarchal and sexist. So how did that end up here? So one of the reconstructions, this is all theory, so there's no direct proof that it happened that way, is that the Kurgan people, the Yanmaya people from the steppe mentioned in last lecture, that came around 8,000 years ago from the steppe region between the Dniester River and the Ural, what is today Russia, down into what today is Persia and Mesopotamia, and conquered large parts of India and Europe over the following 2,000 or 3,000 years. That these people had a very strict binary way of organizing their society into warriors and women, so to say. So, and imposed that onto the cultures that they conquered, which was not Mesopotamia, by the way. So Mesopotamia is a different ethnical, cultural region. But over time, this discriminating kind of sexist, patriarchal way of society trickled into other cultures as well. This is some theory that has I would say there's some evidence genetically that that happened that way. I mean, thinking of the spread of the genes, in particular the men's side, only the Y chromosome might spread into these regions, which of course tells a brutal story of how the conquest actually went. So there is some evidence for that, but it is not totally conclusive, and it is of course prehistorical. But we see that that society is changed over the time from a more egalitarian to a more patriarchal way. Uh, so back from these rather unpleasant and disturbing sides of writing, I mean, writing these oppressive rules that no longer were just verbal rules that could be easily changed, but would actually be kind of these harsh, cast in stone rules that would stay forever. Now, maybe we see a more pleasant side of writing as well. So it's not all about making things immortal that oppress people. It's also about making things immortal that are beautiful and that are literature and knowledge. And one of the most magnificent finds that we have of the Mesopotamian times is the library of Ashurbanipal. So Ashurbanipal was a king in 7th century Assur in the city of Nineveh, another city with more than 100,000 people. So this Babylonian king had this library of many thousand volumes, probably not only written in clay, but also in other forms like parchment or papyrus, so like old forms of paper. However, in 612, before our time, so it was about like maybe 50, 60 years after the library was built, Nineveh was conquered and the library was burned down. So what was, of course, unfortunate for the manuscripts written on more perishable sheets like parchment or paper was very fortunate for the clay. Because what happened with burning down the library is that the clay was burned and that made it durable. And so we have all these clay tablets preserved to our time. And the majority of what we have in literature and poetry and knowledge about the time of Ashurbanipal, the time of 600 to 700 BCE, is through these burned books. It is the Epic of Gilgamesh, for example, which is one of the earliest mythical and legendary texts of the heroic deeds of the legendary founder of Babylon. The Babylonian creation myth, the Enuma Elish, then other myths like the Epic of Anzu, or the Poor Men of Nippur, which is kind of the same plot as the Arabian Nights, the 1001 Night. So all this we have in Ashurbanipal's library, from which you see a display here again in the British Museum in London. So all different shapes written intricately in cuneiform form. And here you have Ashurbanipal hunting lions with his dog in a stone tablet in the British Museum. This is contemporary of his time cuneiform, so big inscriptions writing on a wall. So other examples so of these writings in a relief. So you see that combined with pictures, you have the story that they tell. Around 300 before our time, there was a revival of the cuneiform, even under the Sassanids. So in the whole area of today's Iraq and Iran, the cuneiform were revived, and this is an example of an astronomical text that has calculations of assumed distances of the stars in the sky. Oh, this is a particularly beautiful one, also in the British Museum from the 8th century. So that's about the time of Ashurbanipal, a bit earlier. So it is the map of Babylon. It is actually basically the world map at its time. So you see Babylon, you see the Euphrates and the Tigris rivers with the Shatt el Arab, the estuary of the two rivers into the Persian Gulf. And it tells the story of a great flood that swept away all of humankind except of very few people who survived in an ark, in a big boat, and landed on the mountains of Urartu, which is at the rim of the world in the north, which of course is the Mount of Ararat in the Bible, and it's the story of Noah's Ark. I mean, you know that the Israelites, as we read in the Old Testament, were brought to Babylon, and so they learned of all the Babylonian literature and sciences and brought that back to Palestine. Here you see it better with this overlay. You see the rim of the world, you see other geographic features, and the city of Babylon right in the center of the world. So let's go back for a moment to the development of phonographic, of sound representing signs. As we have seen in this nice chart, in these three different language systems, the cuneiform, the Egyptian writing, and the Chinese writing. So what that shows you is that there is at first an iconic representation like the fish, and by the means of this object, the sound value gets expressed. So, and that is called a rebus, and that is one of the most amazing inventions or concepts in the technology of communication, in the culture of communication, is this concept that you have objects, and by the means of these objects, you represent something different. So that's just a Latin word. Rebus means by through objects, by the means of objects. So there are very ideographic or logographic languages, languages where many signs in the language represent whole words. So where we are still at the level of, I mean, you depict the fish, even if it's kind of abstracted, and it means fish. And I've heard that often, that people say that Chinese is a language that is fully like that, but actually it is not, as I've been shown. So I don't speak any Chinese, so I rely on people telling me that. So an example that I was being given by a Chinese colleague is how the Chinese would represent words that are not native Chinese. Like, for example, the names of these American states. They have no counterpart in the Chinese letters, and still you can transliterate the sound values with Chinese characters. And that shows very clearly that Chinese, although many Chinese characters are used in text as full logograms representing the whole word, whole concept, or at least the syllable, that they can use in this phonetical way, like syllabically representing the sounds of the states in the way Chinese people can pronounce that. I mean, these sounds are unfamiliar to the Chinese tongue, of course. So in both alphabets, the Chinese and the Japanese use symbols to represent sounds. The Japanese in particular came up with two further alphabets that are only for sounds, which are the hiragana and katakana, which are used, the hiragana to add the sounds that are not native, that can't be represented by the Chinese letters that the Japanese took over. And the katakana, which is very similar to the hiragana, to represent foreign words. So this representing language in sounds is an interesting phenomenon, because there was always this debate, and many people debate that still, that it would be possible for people in China, for example, Chinese native speakers, to see a logogram, for example, of the word fish, and only think of a fish and not hear the word fish in Chinese, of course. And so a research group in the 1990s that I remember from my own time working in anthropology at that time, in Leipzig, focused on that phenomenon, and this is the setup that they used. So they used measurements, electrode measurements of the activation of the nerves in the mouth. So if you talk, of course, there's nervous impulses coming from your brain into the muscles of your mouth, activating the contraction or release of your muscles, of the jawbone, of your lips, and of course of your tongue and the vocal cords. And if you have a electrode and a good electric measurement system, you can map that out and see which nerves are actually activated. And what people did is they let native Chinese speakers and people who acquire the language as a second language read a Chinese text aloud, and then ask a second batch of people to just look at the text and read it silently. And what it clearly showed is that the impulses of nervous electricity moving down from the brain into the muscles of your mouth are the same. So it is as if people would read silently, but would formulate what they read in their mouth. But it is very subtle, so you can't see the movements and no sound is created. And the same is true for people who are natively or secondary speakers of European languages. So there was another batch of people who speak German or English as their first or second language, the same results. And it shows that it is at least very likely that there is not just the concept of a fish that can be represented by a sign, but there's something in between which has to do with language. Yeah, sounds and symbols are connected, as we have seen, and depending on which language you speak, you might have more symbols or more sounds represented in that language. So this is again from Robinson's book. It's kind of a schematic that shows how much language is purely logographic. And as we have seen, even Chinese, the most logographic of all languages spoken today, is not fully logographic, but has a phonographic aspect to it as well. And then on the other side of the spectrum, we have some of the European languages, in particular Finnish, which I also don't speak, but I believe Robinson here, which the letters are purely phonographic. And as we all know, in English, that is not really the case. The letters might be pronounced completely differently depending on the word. For example, the letter A might be pronounced A or A or So there is not a one-on-one phonetic representation. And this is why we have phonetic notation developed. And you see that, of course, in dictionaries that you have several different approaches to have a phonetically correct transliteration. So, I mean, not every writing system is an alphabet, as mentioned. So an alphabet is the very specific way of writing that came from the Mesopotamia and is now all over Europe and the Middle East. However, for the sake of using normal language, we will call it an alphabet, even if it is Chinese letters. And what we define as the alphabet here, I mean, this is the definition of the Oxford Dictionary, is that it is a set of written symbols that have an order. So that is the alphabetic order, which is an interesting definition. And the second, that they represent letters of a written language, whatever a letter is. I mean, it's kind of cyclical. So an alphabet consists of letters and numerals and other characters representing a language. So we have a full representation of everything that can be expressed in that language. I think this is the importance of the alphabet, so that it is complete. You don't miss anything. There is no word in your language that you can't express in your alphabet. And by that, what we have just seen 2 slides ago is that the Chinese have a full system of writing, of course. They can express any sound, any word, even if it is not at all Chinese, by means of this phonographic transliteration. Well, now we look into the development of some of these ancient alphabets. The cuneiform we have already seen. So, I mean, but of course, the most famous of all ancient alphabets is that of the old Egyptians, the hieroglyphs, which emerged about 6,000 years ago in what is today still Egypt, around the river Nile. So the hieroglyphs were still in use and understood in late antiquity. So people at that time, around like 300 of our time, 1500 years ago, from now, 1700 years ago, there was still knowledge what the hieroglyphs meant. However, that was then lost. And around the year 1000 already, hieroglyphs could no longer be read. And there's a long history of people trying to decipher these inscriptions. So in Islamic times, I mean, when Egypt was part of the caliphates, there was, of course, scholars, Arabic-speaking scholars, like Ibn Wahshiyya, in the 10th century of our time, which is the 3rd century in the Hijri calendar, and he was on the right track. I mean, he saw, as this is from a manuscript, it's much later, it's 500 years later, it's in the French National Library in Paris, but it is a manuscript, it's a copy of his original manuscript, and you see that he was on the right track in understanding that some of the hieroglyphs can be seen as letters, and some can be seen as whole concepts. So as you see here, for example, with the bird, which Ibn Wahshiyya believed to mean God. In many of the words, he was wrong, but the idea was right. He was just lacking a proper tool to understand, to be able to actually convey the meaning into the letters. That took another 800 years until around 1800. So Napoleon Bonaparte, the Emperor of France, who took over the power in France after the French Revolution in the late 1700s, he went to Egypt to conquer Egypt for the French Empire. That failed. The British came and chased him away, but nevertheless, a lot of French scholars came with Napoleon to study the culture for the first time in a systematic way from this European perspective. So that is the first time when Europeans had started to understand what was happening there. So one of these scholars who came with Napoleon was Fourier. Is a very famous mathematician. Fourier, known of the Fourier transformation, and Fourier was already thinking that there was maybe a combination in the hieroglyphs between letters and logograms, but he couldn't figure it out. He had a pupil of the name Champollion, Jean-François Champollion. And Champollion, 20 years later, in 1822, made the breakthrough discovery by studying an artifact of late hieroglyphic times, the so-called Rosetta Stone. The Rosetta Stone was discovered by the Napoleonic expedition, but was then lost to the British, and the British also immediately saw the enormous importance of that inscription and brought it to London, and it is now on display in the British Museum. It's one of the major magnets for the audience, as you see here, always besieged by people taking a photo, including myself, as you see here. So you see immediately that it is not only hieroglyphs, it is two other alphabets also. So the stone shows the hieroglyphs in the top part, which is damaged. Most of it is lost, and you see some of these hieroglyphs being encircled, what the French would call cartouche. So cartouche means a shell of ammunition, or a box in which you carry things like botany collectibles. So that's a cartouche. And so they call this a cartouche, and this name stuck. And this cartouche here, you can see the letters written out, is seen in many places the same way. Many places where you have hieroglyphs of that time, which is around 300 before our time. It is the time in which Egypt was no longer governed by the Egyptians, but by descendants of Alexander the Great, who came from Macedonia. So he is a Greek or Macedonian speaking conqueror, and his descendants were the so-called Ptolemies, the kings of Egypt at that time. And that explains why you have in the lower part another alphabet, which is Greek. And if you look closely, you see that the name Ptolemies is written in Greek. So it says Basileus Ptolemies. So Basileus is a king, and Ptolemies is Ptolemy in Greek. And in the middle, you have another alphabet that at that time was also not deciphered yet, which is Demotic. So Demotic is Coptic. That is a language that derived from the ancient Egyptian, and has a much more modern-looking alphabet in which it is written. So luckily, there were a lot of inscriptions at that time available for Champollion, who worked in Paris. So Champollion knew another writing, the so-called Philae obelisk, that was brought to England around the same time. So and then published in books. And if you compare the two writings, it's almost the same. So you see the Philly obelisks had on the left hand side exactly the same letters. It's just a bit different on the right hand side. The last letters are a bit different. So there's two more letters in the Rosetta Stone. And there's other inscriptions that were known already to mean the word Cleopatra. So Cleopatra was a queen around Caesar's times, which is around the year 45 BC. So that's 2050 years ago, approximately, so in Roman times. And her name was known in transliteration so it was not known that it is the letters, but these symbols, these hieroglyphs, were known to mean the word Cleopatra. So Champollion now knew that this cartouche on the Rosetta Stone probably meant the name Ptolemy, and he knew that these left-hand side hieroglyphs meant the name Cleopatra. And then it's very easy to see, well, there is, for example, the L, it's the second hieroglyph in Cleopatra because it's the fourth hieroglyph in Ptolemy. And by using that, he could climb up into deciphering more and more of the hieroglyphs. However, not all hieroglyphs are letters. Many hieroglyphs are also representing logographic concepts. And Champollion was able to understand that by his knowledge in Coptic. So the Coptic language was still spoken in Champollion's time by the Copts in Egypt, which are mainly Christian people living in Egypt to this day. And there are Coptic words that he could find resembled in the hieroglyphs, and then also represented by single letters that resembled the demotic. So he would work his way through letter by letter, and then when he finally figured that all out, he would go on an expedition down the Nile to Luxor in Egypt, where there is this magnificent temples with all written over the stone walls and the columns, and would just stand there and read it. He was so eager to get there that, despite they would land with their boats on the Nile, on the shore of the Nile in the middle of the late evening, they would still go on into the temples in the middle of the night with lamps, would start reading and immediately see that Champollion's system would work because they could read in it as in a book. So let's look at this digital version of the Rosetta Stone made by the University of Leipzig. So as you see, there is a photograph of the stone, and it's totally beautiful how you can actually compare the three readings in parallel. So if you look at any of the lines in the Greek, you see it in the Demotic, and as far as it exists, at least in the hieroglyphs as well. I think that's one of the great things in computers, that we have these things at hand now, and it is no longer necessary to go to London to get access to that stone to study it. We have a perfectly well digitized version of it here. Not all alphabets are as well understood as the hieroglyphs or the cuneiforms. There are writing systems of civilizations that were as important as Mesopotamia or Egypt that are much more enigmatic to us. It is really the luck that we understand so much of what was going on in Mesopotamia and Egypt, by being able to read what people were writing at that time. By that, these two cultures are not prehistoric, they are historic. We can read their own accounts on what happened in their times, how they lived, and many other aspects of how they thought, their religions, all is well understood. The same is true in China because the writing in China has a continuation since the earliest time. The same in many parts of India, as we shall see. Not, however, in the Indus Valley, which is a large and one of the earliest civilizations. About 5 to 6,000 years ago, it starts and ends around 4,000 years ago. So the Indus Valley civilization was around the Indus Valley and spun more into parts of what is today Pakistan and North India. And they clearly had some kind of script and writing system, however, didn't use it very much on big inscriptions. At least we don't have any. They only used it for these seals and other tiny pieces of clay or stone on which they engraved their symbols together with pictures. And we have thousands of these, but the longest inscription is only 35 letters long. Most of them are like between 6 and 12 letters only. And that is way too short to understand what they mean. So people have tried to understand that, like Alexander Cunningham, who was a scholar of Indian history, who tried to connect the Indus River Valley to the Brahmi writing system, the predecessor of today's writing system in Hindi. He could, however, not establish any meaningful system. So this is interesting to look at. It's totally enigmatic to this day. Unfortunate. It's not the only example of an undeciphered script. Another one is the writing of the Etruscans. So the Etruscans were people living in northern Italy in the time when the Roman Empire started to form. And the Etruscans had a very highly sophisticated culture. They had cities, they had temples, beautiful burial sites. If you ever go to Italy, all of Tuscany and the north of Rome, the landscape is full of that. Unfortunately, they seemed not to care much of writing down what they were thinking, except gravestones. So the only things that we have of this Etruscan language is gravestones. And I mean, think of learning English only by looking at gravestones. You wouldn't get very far. The Etruscans didn't have their own alphabet. They used the Greek alphabet. That's even more unfortunate. So we could actually read it if they only had written something. Speaking of Greek, so the Greek alphabet as we have it now didn't exist from the beginning, obviously. So in the 18th or early 19th century, scholars in the West started to study scripts in the newly discovered palace of Knossos on the Greek island of Crete. And what people saw in this palace of Knossos is that it is much earlier than most of the mainland Greek, like Athens or Sparta. And so the writing was seen as predating what is today the Greek alphabet of classic times. So the writing in Knossos and other parts of Crete exists in two forms, linear A and B. Linear means that it goes in a line, obviously. And the linear B is a syllabic script by which the Mycenaean Greek was written down around 1500 before our time, so that is about 3,500 years ago. It is 87 syllabic signs and over 100 logograms, so signs that don't represent a sound but a whole word. That is, the most common words stayed in their symbol. They don't have phonetic values. So they were deciphered in the 20th century by a British architect and language scholar, the name Michael Ventris. And Ventris is one of these heroes of decipherment. It's an interesting story to read. So it's an example, again, from the British Museum of the linear B. But as you can gather, since there's a linear B, there's a linear A as well. And linear A to this date is not deciphered yet. So there's still a lot to do. So all these writing systems that we have in Europe now and in the Middle East have these distinct letters that stand for sounds. So this is an example of early Arabic writing, that's Aramaic. It is a stone found in Melilla in Sharjah. So it's about 220 before our time. So it's more than 2,200 years old, and was part of this necropolis, of this burial site in Melilla of the early Iron Age, of the pre-Islamic time, the High Iron Age. Sorry. And this memorial stone reads, it's the grave of Amid, the son of Jr. And we can read it still because we know Aramaic and we can see this script from which modern Arabic is derived. If you look at the letters and think of the Latin alphabet and think of the Greek alphabet and think of the Cyrillic alphabet, you clearly see that there is a connection. And indeed, these alphabets are connected one with each other. So if you look at these tables, you see that they all have a root in the Phoenician alphabet. So the Phoenicians were another culture that lived in the East Mediterranean area. And they were at first representing only consonants, and by that have a purely consonantic writing, as most of today's Arabic or Hebrew is. And the Greek would take that over. However, we're not satisfied with having only consonants, and there's not that many vowels in Greek, and they're very simple vowels, only 5 vowels. So the Greek would add the vowels and later would add diacritics, so signs that would make it more explicit what the sound is actually representing that is written by the letter. So you see if you think of the letter Aleph, how it evolves from the Phoenician into the Greek alpha or into the Hebrew Aleph or the Arabic Alif. Or if you look at the bet, the Greek beta, the Hebrew bet, the Arab ba. So, and now we have the alphabet, which is of course the Greek, the alpha beta, the aleph bet in Hebrew, the alif ba in Arabic, all rooting in the same ancient script of Phoenicia. I'm just to give you the historic context, I mean, the time scale on which we talk here. So the first emergence of writing, so when the proto-writing, the representing things by making carvings into bones or making these clay tablets or clay tokens representing quantities, for example, of crop or cattle, into letters that would represent more abstract values of sound or objects. This is about 5,000 to 6,000 years ago. It is around 3,400 when the city of Babylon or the other cities of Mesopotamia exceeded the size that could easily be governed just by handshake deals or just memorizing law and having just an oral culture. So at that time, proper accounting and proper laws were necessary to keep peace and a flourishing economy. And this is how the archaic texts start, with these mundane economic writings. And from there, we have this kind of progression into the Sumerian, into the Assyrian, and then later the Old Persian alphabet. So this is the first 3,000 years of writing. And from the very old cuneiforms of that time, you can derive most of today's Middle Eastern and European alphabets. So many of that is archaeologically proven, some of it is more hypothetical, but if you look at the alphabets, you see the connections, and you have seen the Phoenician descendants into the modern European alphabets like Latin, Greek, or Cyrillic. Then the Semitic alphabets like Arabic or Hebrew, and then the Amharic, which is the alphabet in use in Ethiopia. So all have one root, which is Mesopotamia, today's Iraq. If you compare not historically, but in the logic of what an alphabet carries, you get to a slightly different descendants here. This tree shows kind of this development from pictures to logograms to this proto-writing and rebus symbols into the full writing systems. Full writing means that you can express anything, any word that you could think of in written form. And so you have syllabic systems like, for example, Chinese, that can also have logograms that are not syllabic but have a full word in one character. And these syllabic systems in the East, of course, developed independently, is believed now, from the Mesopotamic legacy, which is the Sumerian, the logosyllabic system. It's kind of the second from the left here, which went into Egyptian, into Phoenician, which went into Greek, Latin, and all the European alphabetic systems. And in parallel, we have, of course, the Phoenician going into Hebrew and Arabic, and the Chinese going into the Japanese and the Japanese hiragana and katakana syllabic writings. And then you have in the Americas a completely independent development of a logosyllabic systems in the Mayan alphabet, which we will look a bit closer in the next lecture when we look into. So, as we have seen in the example of the book by Ibn Bahashia, written 1,000 years ago, that people found alphabets a fascinating thing. I mean, the caliphate, the influence sphere of Islam at that time was huge. It went from the Atlantic Ocean, from what is today Spain, all across North Africa, way into the east to South Asia. And so there were many alphabets in that sphere that could be studied, and Ibn Wahshiyya tried to put together this comprehensive guide on all the alphabets, including, as we've seen, the hieroglyphs. In Europe, it took, as so often, a bit longer that people found it so interesting, probably also because they were not encountering so many different alphabets. I mean, Latin and Greek are pretty close to each other anyway, so you don't need that kind of elaborate dictionary for it. But in the age of the so-called Enlightenment, in the 1600s, in the Baroque time, we find people starting to study the comparative structure of languages and alphabets. As this example, Edward Barnard, he is a professor of language in Oxford in the 1650s, so a bit more than 400 years ago. And in his beautiful book and tables, you find also all the hieroglyphs there. Well, I mean, the fascination of alphabets that produced us so many beautiful books and scripture was kind of really under threat when digital technology took over. So when I started using computers in the 1980s, there were not many different alphabets. Actually, there was just one, and that was the English alphabet. Thanks to the standardization of the representation of characters in computers that took place in the 1950s and 60s, in particular by the invention of the American Standard Code for Information Interchange, ASCII, in 1960. And ASCII, I mean, made just concessions to how small computers were at that time. So computers would have tiny amounts of memory. I mean, much less memory than any Arduino circuitry that you will make in your IM classes in the future nowadays has. So really tiny amounts of memory could be stored. And so you better be very careful how much memory you allocate for the representation of letters. And so people choose just 1 byte of information per letter. There were people even thinking that that is too much, that it should be only 7 bits. But for economic reasons, and since the memory is organized in bytes, the ASCII standard is 2 to the 8. That means 256 different characters. And yes, you see here, if you think of the limitation of that space, I mean, you have the alphabet. It's 26 letters in the English alphabets, no umlauts, no special characters. That means 52 if you have lowercase and uppercase. Then you need, of course, all the punctuation, the brackets, parentheses, the hyphens, and so on. You need signs that tell, for example, a new line, or to move the cursor 1 space ahead, and so on. So the 256 is actually no luxury. It fills pretty quickly. So no wonder that people were not very kind of imaginative that others might actually want to express their language properly as well. So if you see my name written, as I usually do, my name in German is written in a different way. So the OE in my first name is actually an O with umlaut. So it's Ö. Jörg is my first name. This letter obviously doesn't exist in English, and so I could not write it on computers. And this is why I changed the name. That was kind of giving in and always losing the battle, that people would not be able to display my name properly in presentations or in written texts. Yeah, and I mean, of course, I'm not the only person who faced that fate. I mean, the whole cultures, I mean, like people writing in Arabic or people writing in, I mean, these much more complicated logographic systems like Chinese or Japanese or Korean, which were totally lost. I mean, these are cultures, as we will see, who had print and a concept of letters much earlier than people in Europe had. However, in computers, we have the full power of imperialism taking over and forcing the very limitation of the English alphabet for quite a while onto everyone else. This changed in the late 80s. So people were not satisfied with that. I mean, people were more thoughtful than we might give them credit now. And in particular, it was people in companies who wanted to export their technology to other parts of the world, like Xerox or Apple. In particular, the two of them, Xerox and Apple, started working in 1987 to opening up the system of ASCII into a more general representation of letters, which they called Unicode. And in 1988, Adobe, Microsoft, and IBM joined the consortium that they formed to come up with this numerical representation of possibly all the alphabets in 2 bytes. I mean, if you think of 1 byte, 2 to the 8, that is about 256 letters. So with 2 to the 16, you can express more than 1 million and still have all the logistical characters that are not displayed as well. So there is not 1 million different characters in the world. So that is a system that should actually be sufficient. But let's have a look at that. It's absolutely worthwhile giving it a bit closer inspection. So let me find my cursor. So this is the Unicode Consortium homepage. I mean, you see they advertise in the diversity that they have. So the organization of the Unicode characters is in so-called charts. And that makes, of course, sense. I mean, it makes sense that you have some kind of logic structure in it. So you see all the different writing systems. I mean, isn't that beautiful that you have it all? Like all the current, for example, European systems, but also the extinct ones as linear A and B, as we have just seen. Like, for example, here, the cuneiforms. And you can represent these by just putting into this value into your HTML code on any web page, and every modern browser should be able to display. So the cuneiforms, for example, is their numerical expression. Or here, for example, Malayalam, the alphabet that is written in Kerala in South India. So first time ever, we have a digital system that is not discriminating, that is actually able to display characters of all the alphabets. And I think this is a great achievement. It's really something to be proud of. So, yeah, I just given the example of a cuneiform as we have seen. I mean, this is how it looks in HTML. You just have the ampersand letter, the number sign, and X. That means it is in hexadecimal representation. You can also just have the numbers, which is 4 or 5 digits. Then it is decimal. It is usually more convenient to have the hexadecimal because that's shorter. And then out comes the cuneiform character here. And I mean, the kind of miracle that we all have experienced recently is that we can use Unicode, of course, to convey important messages in every people's language and make it very inclusive for people. I mean, as here on campus, where you see the safety instructions to stay healthy, not only in English and in Arabic, but also in Chinese, in Urdu, in Hindi, and in Tagalog. And you can, of course, continue that as far as it goes. Yeah, Unicode, I think, is an important technology in communication that bridges the history of the alphabet with the very modern times of the digital age, and in between, printing and making books and texts with printed letters. It shows you that we can actually have something like progress in technology if we only want. We don't need to get stuck in imperialism and colonialist thoughts. We have a chance now to see the world with different eyes or listen to the world in different tongues. And with that, we close for today. And next chapter, we will look into more advanced even technologies of communication, which is books and libraries.